In this video we will discuss about vectors briefly but not completely, a little bit. Okay, so you already know what a vector is, so the basics of the vectors I will not be explaining. Let us try to understand few things which we come across most frequently while solving the problems. Okay, something like first, what's unit vector? So unit vector is a vector which has a magnitude equal to 1. Basically the unit in the name tells us that it has a magnitude of 1. That's what a unit vector is. Vector of magnitude equal to 1. Okay, so the definition or the defining unit vector is very important because this is fundamental to explaining all of vectors. Okay, so any vector we represent as sum of its components along x, y and z axis. Okay, I hope you remember resolving a vector into components. So when we resolve a vector into components, basically something like x component, y component and z component. Okay, so in order to be able to write the vector as sum of its components, first we must define unit vectors along those three particular directions. Okay, so we basically take a unit vector along x axis to be I cap, or parallel to y axis to be j cap, and parallel to z axis to be k cap. Okay, so we call a unit vector along x axis I cap, along y axis j cap and along z axis k cap. Then we take a unit vector in the negative x direction as minus I cap, in the negative y direction as minus j cap, and in the negative z direction as minus k cap. Okay, so these are all the unit vectors along x, y and z axis. Okay, next, let's say they can ask you a question something like this. Let's say we have a vector a bar is equal to 2i cap plus 3j cap plus 4k cap. How do we find a unit vector along the direction of a bar? Okay, so remember one point, any vector can be written as a product of its magnitude and a unit vector in its direction. So here a cap basically represents unit vector along direction of a bar or parallel to a bar. So I can write a cap is equal to a bar divided by magnitude of a bar, which is equal to, a bar is basically the vector that we have, which is 2i cap plus 3j cap plus 4k cap divided by, so the magnitude of a bar. Okay, so how do we find magnitude of a bar? Root of 2 square plus 3 square plus 4 square. Okay, so how did I write this? If we have a vector something like this, xi cap plus yj cap plus zk cap, the magnitude of this particular vector is given by root of x square plus y square plus z square. Okay, where x, y and z are said to be the components of that particular vector, so along x, y and z axis. So this is how we find a vector, a unit vector parallel to the direction of a particular vector. Now let's say, okay, our intention is to find a unit vector in the opposite direction of a bar. So this was a bar, and the unit vector in the direction of a bar is represented with a cap. Okay, now if I wish to represent a unit vector in the opposite direction of a bar, okay, it's basically minus a cap. Okay, so if unit vector in the right direction is a cap, unit vector in the opposite direction would be minus a cap. So the minus basically tells us the vector you have taken, that is minus a cap, is in the opposite direction of a cap. So both a cap, okay, and minus a cap would have the same magnitude, which will be equal to 1. This is because whenever any vector is multiply it with a negative symbol, the new vector that you get will be in opposite direction to the original vector, but the magnitude doesn't basically change. So that's why a cap and minus a cap have same magnitude, but the difference between them is that they are in the opposite directions. Okay, so the same thing can be said about the negative of a vector. So if suppose, let's say we have vector a bar here and we wish to represent minus a bar. So minus a bar would have the same magnitude of a bar, but the difference between a bar and minus a bar would be they are going to be in opposite directions. So this is about a unit vector. Now let's discuss about resolving a vector into components, or we can call it as resolution of a vector. Okay, so let's say we have a vector. Let's take basically in 3D space. Okay, so let's say x, y, z. Let's say we have a vector, okay, something like a bar. Okay, let's say its magnitude is represented with a. So this vector a bar, it might be making some angle alpha with x-axis, beta with y-axis, and gamma. Okay, it's difficult to represent gamma here. Gamma with z-axis. So imagine this in 3D space. Here, though I've represented it on the screen, it looks like it's in the xy plane, but it's not actually in the xy plane. I mean, it may be in xy plane, but necessarily need not be in xy plane. So it could basically be making a certain angle with three of those axes. So if it was making, if it was in the xy plane, the gamma angle or the angle made by that vector with the z-axis would be 90 degrees. Okay, so here, so alpha, beta, gamma are the angles made by that particular vector with the three of those axes. Then we call cos alpha, cos beta and cos gamma, these are said to be the direction cosines of that particular of a bar. So why we call them as a direction cosines is because we have taken the cosines of those angles, and these three independent values tell us actually about the direction of that particular vector. Okay, so now if we wish to resolve this vector a bar into three components, so x component of it would be a cos alpha. A represents the magnitude of the vector into cosine of the angle made with that particular axis, and the y component would basically be a cos beta, and whereas the z component of that particular vector would be a cos gamma. So these are the magnitudes of x, y and z components. Okay, so basically this is how they are going to be: ax parallel to x-axis, ay parallel to y-axis, and az parallel to z-axis. Now I wish to represent this vector a bar as the sum of its three components, that are x, y and z components. So I can write it something like this. First, this x component is parallel to the x-axis, so in vector form we can write it as ax, where ax represents its x component into I cap, and its y component can be written as ay into j cap, and z component can be written as az into k cap. Here az only gives us the magnitude, but to take, when we consider the direction, okay, so when you multiply with the k cap, so it tells us that it has the z component has a magnitude az and it's along z axis. Okay, or we can also write it as a cos alpha plus I cap, plus a cos beta j cap plus a cos gamma k cap. So this is the vector a bar is going to be. Okay. Next, if we proceed with finding the magnitude of that, so the magnitude of a bar is basically a. If we proceed with that, we would get a cos square alpha plus cos square beta plus cos square gamma is equal to 1, where alpha, beta, gamma are the angles made by that vector with x, y and z axis. Okay, And we know the trigonometric identity that cos square theta plus sin square theta is equal to 1. So if we make use of that here, cos square alpha can be written as 1 minus sin square alpha, cos square beta can be written as 1 minus sin square beta, plus cos square gamma can be written as 1 minus sin square gamma. If we simplify this, we will get it as sin square alpha plus sin square beta plus sin square gamma is equal to 2. Okay, so these two relations, it's better to memorize them. Okay, they would help. But most of the times when we are dealing with the resolution of a vector, basically we be discussing vectors which are in a plane. Okay, so imagine if we have a vector, let's say in a simple case where it's in xy plane. If the vector is in xy plane, let's call it a bar. This is alpha, this is beta. Since it's in the xy plane, definitely the angle made by it with the z-axis would be 90 degrees, because a bar is in the xy plane, but whereas z-axis is perpendicular to xy plane, so hence z-axis would be perpendicular to a bar as well. So in such a scenario, gamma would be 90 degrees. And next thing, the sum of alpha and beta would also be 90 degrees. So now if we look at the components, so the x component would basically be a cos alpha, whereas y component would be a cos beta. In the place of beta, I can write 90 minus alpha, so we get a cos of 90 minus alpha. Cos of 90 minus alpha is sin alpha, and clearly the z component would be a cos 90 degrees, which would be equal to 0. Okay, so we can basically write this vector. In this case, a bar is equal to x component can be written as a cos alpha I cap, and y component can be written as a sin alpha j cap. Okay, so here see that since it was making an angle alpha with x axis, okay, so we got the x component to be cos component, whereas the sin component to be the y component. Now in the same vector a bar, if we wish to represent in terms of the angle made by it with the y axis, then we would get the x component as a sin beta I cap, plus y component would come out as a cos beta j cap. The same vector could also be written something like this. Okay, so now we have understood the resolution of a vector. Okay, now so you already know the negative of a vector, what it means, and I hope you also know the multiplication of a vector by a scalar. Let's discuss that with a simple example. Let's say we have a vector a bar whose magnitude is given by 2. Let's say a bar is in this particular direction. Then let's say a bar is multiplied with some scalar. Okay, the scalar could be either positive or negative. Let's say it's multiplied with 3. Then you get a new vector 3a bar. So the magnitude of 3a bar would be basically 3 times the magnitude of a bar. But what about the direction of 3a bar? Since a bar is multiplied with a positive number, which is plus 3, so 3a bar would be in the direction of a bar. Okay, but its magnitude would be 3 times that of a bar, so it's basically its magnitude would be equal to 6. Okay, then suppose let's say instead of multiplying a bar with a positive scalar, let's say it's multiplied with a negative scalar, something like minus 2a bar. Then what about the direction and the magnitude of minus 2a bar when compared with a bar? So minus 2a bar, observe that it's a negative scalar. Okay, so the minus 2a bar would be in the opposite direction of a bar. Okay, so the angle between a bar and minus 2a bar would be 180 degrees. Okay, but what about the direction of minus 2a bar? So the minus 2a bar, okay, here the minus is basically telling us that the vector that we have is in the opposite direction of the original vector, which is a bar. So it doesn't have anything to do with the magnitude. So this would be 2 times the magnitude of A bar, which is 2 times 2, which is equal to 4 units. Okay, so this is the multiplication of a vector by a scalar. Next, let's discuss briefly about triangle law and parallelogram law of vectors. Okay, so because the idea of triangle law is very important in many chapters, okay, wherever you're dealing with the vectors, and also the finding the resultant of a vector using parallelogram law, okay, or cosine law, that is also very important while solving problems. Okay. So what's triangle law of vectors? So triangle law of vectors is basically helpful when we have two vectors, okay, represented diagrammatically, and we wish to find the resultant of those two vectors. Okay, so let's say we have two vectors, something like this, A bar, and the other vector is given by B bar. Okay, so we wish to find the resultant of the two vectors. Okay, the resultant is nothing but the sum of those two vectors. Let's call the resultant as R bar, which is equal to A bar plus B bar. Now I wish to find the sum of these two vectors. So for that, what we will do? First, we will represent one of the two vectors. Let's say we first represent either A bar or B bar, doesn't make any difference. Let's say we represent A bar first. Okay, so we can move a vector parallel to itself. Even if we move, its magnitude and direction doesn't change, so basically the vector hasn't changed. Now we will draw B bar or move it parallel to itself such that both A bar and B bar are in order, okay, or drawn one after the other. So what do I mean by that? So we have to draw B bar in such a way that its tail, just a minute, its tail coincides with the head of the first drawn vector, which is B bar. Okay, now these two vectors are said to be drawn in order. Then the resultant of these two vectors, okay, is basically vector drawn in the reverse order, or drawn from the tail of the first vector and towards the second vector. So this is the R bar. That vector, okay, represents both the magnitude and direction of the resultant of these two. I mean, when you do A bar and B bar, A bar plus B bar, so the resultant, whatever you get, that would be in that particular direction, and its magnitude would be magnitude of this vector R bar. Okay, and one caution while representing the angle between two vectors. So here, if you wish to represent angle between A bar and B bar, draw them in such a way that, okay, redraw them such that their tails are touching each other. In this case, observe this angle alpha is not the angle between A bar and B bar. Okay, so whenever we are representing angle between two vectors, we have to redraw them such that either tails touch each other or heads touch each other. So I will go with tails touching each other. So this would basically be B bar. Then this is theta. Now theta is angle between A bar and B bar. Okay. Now let's proceed with the parallelogram law of vectors. Not going to do the entire derivation. I'll directly give you away the results, okay, which we are going to use most frequently. So let's say we have a vectors, I mean parallelogram law of vector basically follows from triangle law of vectors, but we use a little bit of mathematics in order to arrive at the relation for magnitude of resultant, and also we determine the angle made by the resultant with both of those vectors. Let's say we had two vectors, something like this, A bar and B bar. Okay, so the angle between them is given by theta. Let's draw B bar parallel to itself. Then This is the resultant of these two vectors. Okay, so I've just drawn b bar parallel to itself. Now here the magnitude of resultant is given by root of a square plus b square, where a and b represent the magnitude of a bar and b bar respectively, plus 2ab cos theta. So what does cos theta represent here? The angle between a bar and b bar. Okay, then if alpha is the angle made by the resultant with a bar and beta is the angle made by the resultant with b bar, then we can write tan alpha is equal to b sin theta divided by a plus b cos theta. Similarly, we can also write tan beta is equal to a sin theta divided by b plus a cos theta. Okay, these three are the main relations that we basically obtained from the parallelogram of vectors. And using these three relations, let's discuss a few special cases which we'll be encountering in the problem sometimes. Okay, so now let's say we were dealing with a situation where the two vectors were in the same direction. Okay, so if vectors are in same direction, theta would be equal to 0 degrees. So theta 0 corresponds to vectors in same direction. In such a case, what would happen? The resultant is going to be root of a square plus b square plus 2ab cos 0 degrees, where cos 0 degrees is equal to 1. So we would get r is equal to root of a square plus b square plus 2ab cos 0 degrees is equal to 1. So we know that a square plus b square plus 2ab is nothing but a plus b whole square. So r would basically come out as a plus b. So the resultant of two vectors, okay, if they are in the same direction, would be equal to the sum of the magnitudes. What if theta is 180 degrees, which indicates that the vectors are in opposite direction? Then in that case, the resultant would be root of a square plus b square plus 2ab cos 180. We know that cos 180 degrees is minus 1. So we would get it as root of a square plus b square. Cos 180 is minus 1, so we would get minus 2ab. So that would basically give us the resultant as mod of a minus b. So why did I specifically use the modulus here? See, we don't know whether a is bigger than b or b is bigger than a. Suppose if a is bigger than b, the resultant would have a magnitude equal to a minus b. Okay, so if a is greater than b, in that case resultant would be a minus b. If a is less than b, then in that case the resultant would be b minus a, because see the resultant, the magnitude of a vector can only be positive, it cannot be negative. And what about the direction of these resultants? So in this case, when we are dealing with two vectors in the same direction, the resultant, suppose let's say if both a and b are in same direction, then the resultant would also be in the same direction. But if you have two vectors in opposite direction, let's say a is in this direction, b is in the opposite direction. So as you can clearly see here, so one of the vector, in this example I'm considering b greater than a, so the resultant would be along the direction of the vector of the larger magnitude. So as b has larger magnitude than a, so the resultant would definitely be along the direction of b. Okay, now let's go to the next cases. So if we have a case where theta is equal to 90 degrees, which means both vectors are perpendicular to each other, so something like this. So I'm only representing the magnitudes of vectors here, perpendicular to b, then the resultant would be equal to root of a square plus b square. So the resultant would be something like this. Okay, so for example, if this is b, this is alpha, so we would basically get tan alpha is equal to b by a. Okay, this is what the resultant is going to be. So if, for example, if both, okay, let's take a general case where a is equal to b. So if we are trying to find the resultant of two vectors a bar and b bar, and if their magnitudes are equal, then in such a case, okay, so what would happen is the resultant, if we simplify, so we get it as root of a square. In the place of b also I can write it as a 2 into a into cos theta. So r is equal to root of 2a square plus 2a square cos theta. So this would come out as root of 2a square of 1 plus cos theta. So 1 plus cos theta, I mean, if we use this relation, cos theta is equal to 2 cos square theta by 2 minus 1. So we will end up with root of 2a square of 1 plus 2 cos square theta by 2 minus 1. If we simplify this, we'll get it as 2a cos theta by 2, where theta is the angle between those two vectors a and b. So if these two equal vectors, okay, if we have something like this, just a minute, if these two vectors a bar and b bar are something like this, a bar, b bar, so in this case I'm basically considering both vectors to have the same magnitude, then in that case the resultant will be in a direction in such a way that it makes same angle with both of them. Alpha will be beta, provided the magnitudes of both the vectors is equal. If the magnitudes are not equal, then the resultant will be more closer to the vector with larger magnitude. So what do I mean? Okay, suppose let's say if we have the magnitude of a bar is greater than magnitude of b bar, let's say. So we have two vectors, a bar magnitude is more when compared with b bar, then the resultant would, the resultant would make a smaller angle with a bigger one. Then in such a case alpha would be less than beta. The resultant will make less angle with the vector of larger magnitude and more angle with the vector of smaller magnitude. So these specific cases would be helpful in some problems, okay, if you memorize. So go through these specific cases what I discussed under the parallelogram law of vectors and memorize them, because we will be using them many times. Okay, and then let's discuss a little bit about the product of vectors. Okay, we'll be discussing about two products. One is a dot product and the other is cross product, and how to calculate the product, and also what specific kind of problems they can ask you related to these products. So first, coming to dot product. By now we are already familiar with using the dot product. Basically we use the dot product while calculation of work done, power, and then flux. Okay, so there we have used the dot product, and we have used the cross product while calculating torque, angular momentum, while calculating torque on a dipole, or the general torque relation. Okay, so on. Now let's go back to the dot product, or we can also call it as a scalar product. So what do we mean by dot product or a scalar product? So let's say we have two vectors, okay, a bar and b bar. We wish to find their dot product. So under this section of dot product, we would basically discuss two ways of finding the dot product. One way, okay, the first way, provided I mean, you know the magnitude of both vectors and the angle between them. And in the second method, if they were given in vector form, that is, if the two vectors are given as a sum of their components. So let's say we have two vectors, a bar and b bar. Let's say the angle between them is given by theta. Let's say we know that magnitudes are known. A bar is a, b bar magnitude is b, and angle theta is also known. Then the a bar dot b bar, their dot product can be written as ab cos theta, where a and b are magnitudes of two vectors and theta is the angle between those two vectors. Okay, and this is how you find if you know the magnitudes and angle. What if, let's say, I mean in the second method, okay, so instead of giving the magnitudes, let's say the two vectors, okay, whose dot product has to be found is known in terms of their if two vectors are written as sum of the components bxi cap, byj cap plus bz k cap, then a bar dot b bar can be written as, I mean, axi cap plus ayj cap plus azk cap dot bxi cap plus byj cap plus bzk cap. So if we do the dot product, we will get it as ax bx plus ay by plus az bz. Okay, so if the two vectors are given in terms of their respective components, then this is how we find the dot product of those two vectors. Okay, now let's discuss the problems, okay, how the dot product will help us. First thing, so one of the important points regarding the dot product is, so when we do the dot product of these two vectors, the result that you get would be a scalar, or the result that you get will only have a magnitude but it doesn't have any direction. Hence we also call it as a scalar product, because the output of this product between two vectors is basically a scalar quantity. Okay, that's the reason. Now next thing, the dot product is basically commutative, so we can write a bar dot b bar is equal to b bar dot a bar, and we can also write a bar dot of b bar plus c bar can be written as a bar dot b bar plus a bar dot c bar. Okay, and as you can see here, I mean, so if let's say we have two non-zero vectors a bar and b bar, if the dot product is 0, I mean, keep in mind that I have assumed them to be non-zero vectors, okay, or I am speaking about this point specifically if they are non-zero vectors. So the dot product is 0, which indicates the only possibility is cos theta is 0. It implies theta is 90 degrees. So if two vectors are perpendicular to each other, that is the angle between them is 90 degrees, then the dot product of those two vectors is definitely 0. So this point is very important in determining if two vectors are perpendicular or not. So if you wish to find whether the two vectors are perpendicular or not, find the dot product. If it comes out to be 0, that means those two vectors are perpendicular or orthogonal. Okay, now sometimes they might ask you a question something like this. I mean, let's say find angle between, let's say our intention is to find a bar is equal to, I mean, let's say we have two vectors 2i cap plus 3j cap minus k cap, and we have another vector b bar is equal to I cap plus 4j cap minus k cap. So our main intention is to find the angle between these two vectors. So as we earlier discussed, we can write a bar dot b bar is equal to AB cos theta, or I can write cos theta is equal to A bar dot B bar divided by A into B. So here the A and B that you see in the denominator are basically the magnitudes of those two vectors. Or we can write theta is equal to cos inverse of A bar dot B bar divided by A into B. Okay. So since both vectors are given in vector form, that is in terms of their respective components, okay, so we can find the dot product easily. A bar dot B bar, if you calculate, you will get it as 2 into 1 plus 3 into 4 plus minus 1 into minus 1. So this would be 2 plus 12 plus 1, which would be 15. Then what is A equal to? A would be magnitude of A bar, which is root of 2 square plus 3 square plus 1 square, which is equal to root 14. Then what about B? Magnitude of B bar, root of 1 square plus 4 square plus 1 square, which would be root 18. So the angle between these two vectors will come out as cos inverse of, so A bar dot B bar is 15 divided by root 14 into root 18. Okay, so this is how we find the angle between the two vectors. Now let's say the same dot product, which helped us to determine the angle between two vectors, will also help us to find the angle made by a particular vector with x, y and z axis. So let's say we have a vector something like this: axi cap plus ayj cap plus azk cap. Now our main interest is to find the angle made by this vector with the x, y and z axis. Okay, so we can write cos alpha is equal to ax, its x component, divided by a, where ax represents its x component and of that particular vector, and a represents the magnitude of that vector. So where basically a is equal to root of ax square plus ay square plus az square. Okay. Similarly, cos beta would be equal to ay by a. Similarly, cos gamma is equal to az by a. Okay, so these are the three components, the directional cosines of that particular vector a bar. So the another use of this dot product is, okay, so if we wish to find the component of a vector parallel to the another vector, dot product basically will help us. So what do I mean? So imagine we had two vectors, a bar and b bar. Let's say the vectors were something like this, so where the angle between the two vectors is a bar. Now let's say there was a question something like this, so find component of a bar parallel to b bar. So how are we going to find that? Okay, see here, a bar makes an angle of theta along the direction or parallel to b bar. So we can basically resolve a bar into two components. One component parallel to b bar, since it makes an angle theta along the direction, so we can call, that component is going to be cos component and the other component is going to be sine component. So basically, if you see the diagram, here the component of a bar parallel to b bar is nothing but a cos theta. So a cos theta is what we intend to find. So as you remember from the dot product, we can write ab cos theta is equal to a bar dot b bar. Since we want a cos theta, from here we will write a cos theta is equal to A bar dot B bar divided by B. Okay, so this is the component of the A bar, the magnitude of component of A bar along the direction of B bar. Okay, now let's discuss briefly a little bit about the cross product. Okay, so first, cross product, or it's also called as vector product, because the result that you get, one second, I made a mistake, the cross product or vector product. So if you have two vectors, A bar and B bar, okay, so when you do the cross product of those two vectors, the result that you get is going to be a vector quantity, hence we call it as a vector product as well. Okay, so what would be the magnitude of cross product of two vectors? It would be product of magnitudes of those two individual vectors and sine of angle between them. Okay, so this is what is the magnitude of the cross product of two vectors is going to be. Then what about the direction of that particular cross product? Okay, so in order to find the direction of the cross product, okay, so we can basically use right hand thumb rule. Let's say, so we have two vectors something like this, and I wish to find the direction of A cross B. Okay, so in order to find the A cross B, direction of A cross B, so follow the following steps. First, redraw the vectors in such a way that the tails are touching each other. Then take your right hand, extended right hand, okay, and place the wrist joint at this intersection, okay, and the extended hand along A bar. Now curl fingers towards B bar. So when you curl fingers towards B bar, then the extended thumb will be pointing along the direction of A cross B. In this case, it is going to be outwards. So basically, A cross B in this case is going to be outwards. Similarly, for the same two vectors, if you wish to determine the direction of B cross A, so B cross A, so while finding B cross A, we follow the same procedure. Redraw the two vectors A bar and B bar such that the tails are touching each other. Then take your right hand such that a wrist joint is present at the intersection of those two vectors, or at the point where the two tails are touching each other, such that the extended hand is pointing along B bar, and then curl your fingers towards A bar. Then B cross A will be pointing inwards. So as you can see, so A cross B and B cross A do not have the same direction, but from the basic, okay, understanding of the magnitude of the cross product, so both of them will have the same magnitude. So what we can conclude from this is both A bar and B bar will have same magnitude, but their directions are going to be different. So whenever you have two vectors of same magnitude and in the opposite directions, so we can write one is the negative of the other vector, or in simple terms we can write A cross B is equal to minus B cross A, or we can also write it the other way, B cross A is equal to minus of A cross B. Okay, so basically if you observe, the cross product is not commutative. That's one thing we have to keep in mind. Next thing, the distributive property is valid for cross product. So we can write A cross of B plus C is equal to A bar cross B bar plus A bar cross C bar. So distributive property works well. Okay. So this is how we find the magnitude of cross product if the magnitudes of two vectors are known and angle theta between them is also known. And this is how we find the direction of the cross product using right hand thumb rule if directions of both vectors are known. So what if instead of knowing the magnitudes of both vectors, let's say you know the two vectors, okay, in terms of their components. What do we do in such a case? Let's say we know the three vectors are something like this. B bar is equal to bxi cap plus by j cap plus bzk cap. Then how do we find A cross B? So to find A cross B, we are going to use the determinant method in order to find the cross product of these two vectors. So first what we will do, we will represent a determinant. Okay, so first row will fill with I, j, k. Second row will fill with the components of the first vector, which is A bar. So Ax, Ay, Az. And third row will be filled with components of B bar, Bx, By, Bz. So once we fill with the components, then we will find the determinant of this particular 3x3 matrix that we got. So basically, while finding the determinant, I mean, we would get plus, minus, plus. So I hope you have learnt more about the cofactors and minors in math. Okay. So first we'll write plus I cap, then close the row and column containing the I cap. Then we'll be left with this quantity: Ay, Az, By, Bz. Basically, this is what we'll be left with once we close the row and column containing I cap. So its magnitude, I mean the determinant of this 2x2 matrix would be Ay Bz minus Az By. If we use that, we get Ay Bz minus Az By. Okay, then minus j cap, then close the row and column containing z. Then we'll have Ax Bz minus Az Bx plus, now write plus k cap. Okay, then close the row and column containing k cap. So we would have Ax By minus Ay Bx. So this is how we find the cross product of two vectors when the two vectors are given in terms of their components. Okay, so we'll discuss some problems related to the vectors later. Okay, this is for this video. The next video I'll post some problems and a little bit related to the two-dimensional motion.